Hello Precalc BC. Today we are doing a review of compound interest, which is here. We are going to skip our little section on simple interest here, so please ignore that. And then you can go ahead and you can write down this information here, which should be review. There we go. So compound and on previous interest earned, we have P stands for our principal, which is the amount of money we put down. A stands for our total amount. R is our rate as a decimal, N is the number of compounds per year, and T is the number of years. Different options for N, you could have annual, which would be 1, semi-annual, which is 2, quarterly, which is 4, and again, this is how many times we are compounding. Monthly, which would be 12, because there are 12 months in a year, and daily would be 365. We also have PERT, and PERT is when we are compounding continuously, and we will use E. And just to come back over here, it looks like this got deleted or erased a little bit. This word was earned that was partially erased. Okay, so let's come on down to number 1. Given a starting amount of $1 million, an interest rate of 4.5%, how much money would you have after 15 years if you compounded all of these? Okay, well, I don't think we need to do every single one of these, so let's just do let's do quarterly, let's do continue. Okay, and if you feel like doing annually, monthly, and daily, you certainly can, but I do not feel like it. Again, the only difference is you're going to be changing the value of N for those. And yes, this is a formula that you should have memorized. So let's start with semi-annually. All right, so we have A equals your principal, which is your starting amount of money, which is $1 million. 1 plus your rate as a decimal, so this would be 0.05 over N, which is how many times you are compounding. We are doing semi-annually, so that is 2 to the NT power. So the 2 comes back up, and then time is 15 years. And then this is literally a just type it into your calculator sort of situation. Okay, and I have 1 plus alpha y equals enter, 0.045 over 2 to the 2 times 15 is 30 power. And oops, I lost a 0 there, so I went ahead and put that back in, and I do get this amount here, which is good because otherwise I'm losing money, and that would be bad. So $1,949,393.44 is what I'm getting for A. Make sure you have a dollar sign. All right, so there's semi-annually. So now we're going to do quarterly and 4 quarters. So this is going to be the exact same thing, only this time we are dividing by 4. And again, it's NT for your exponent, so 4 times 15. So all I'm going to do is go back up and grab what I just had in my calculator and then make the necessary adjustments. So I should have done my exponent. So this is a 4, and then up here my exponent will be a 4 times 15, which is a 60. And we can see that it is a little different. I mean, it's not terribly different. We are going to be making a little more money when we compound quarterly, is what I have written down here. Okay, now what's best for you is to be compounding continuously. All right, that's going to get all of the money that you can get. And it's faster to type in, right? Because we're using PERT for compounding continuously. So PE to the RT, so R is 0.045 and T is 15 years. Let's type that in. 1, 2, 3, 4, 5, 6. E to the 0.045 times 15. Oops, there's supposed to be a times in there. All right, and you'll see we've gotten the most. It's not terribly different again, but $1,964,032.98. Okay, so you can find the other ones if you want to, but I'm just not going to. So let's flip. What interest rate is needed to turn $500 into $575 in 2 years if it is compounded quarterly? So interest rate, that means we're trying to find R. And we have turned 500 into 575. So here's your principal. Here's our total amount earned. 2 years, this is our time. And compounded quarterly, this would be our N, which is 4. All right, so let's just plug everything in. So that's the amount earned. Here's our principal, 1 plus the rate we do not know, but we are compounding quarterly, so over 4 to the NT power, so 4 times 2, which is 8. So now to go ahead and solve, what we want to do first is divide by 500 on both sides. So 575 divided by 500, and that's 1.15. Okay, and now what we would want to do is take the 8th root of both sides, or you can write this as raising this to the 1/8 power. And that's going to leave you with this. So then I'm just going to subtract 1. And then multiply everything by 4. And I will type this into mirror. All right, so let's try that. It's going to be 1.15 to the 1/8 power minus 1. And then I'm multiplying that whole thing by 4. Okay, and remember, this is our interest rate. So what I want you to go ahead and do is we're going to round to the nearest thousandth, but we're going to round the interest rate to the nearest thousandth. So go ahead and multiply this guy by 100. And then your interest rate would be 7.049%. All right, so we want to leave it as a percent. Okay, so write it as a percent and then round to the nearest thousandth. Next, how many years will it take to double an investment given an interest rate of 5% if the investment is compounded monthly? So here's a cool thing about this type of problem. It actually doesn't matter what the principal and what the total amount earned is, as long as you show it has doubled. So if we want to say we start with $10 and it becomes $20, great. If we want to start with $5 and it becomes $10, great. It actually does not matter. You just have to pick something. So I'm going to say that it doubled and became $200 and I started with $100. 1 plus interest rate is R, so that's a 0.05 over N, compounding monthly, so that's my 12, to the NT power, so 12, and then time we do not know. So here's why it doesn't matter what amount of money you start with, because you're just going to divide anyways, and regardless of what you have, if you've doubled your money, when you divide, you're going to get a 2. Okay, so if you just want to start with 2, that's fine. All right, and this should make sense because really there's still a 1 here, right? So it's like you started with $1 and you ended up with $2. All right, so now what we would want to do to solve this is just to log both sides. And again, if you want to log base 2 both sides, you can. but I usually just log. Oops. And what that's going to do is that's going to bring down this 12t. And if you want, what might be faster is like this, you can actually find a value for that. So it might be less writing. So 1 plus 0.05 over 12. Let's math frac that. So that's 241 over 240. I don't know if that's better or worse than what it was. All right, so now in order to solve this, all we have to do is divide by 12 log 241 over 240. Now, when you do this, you have to be careful because your calculator gets a little weird if you aren't using the fraction bar. So I really recommend using the fraction bar for these to make sure that you're actually dividing what you want. So this is log 2 over 12 log 241 over 240. So this should be your answer, 13.892 years. If you look, I'm just going to pause it really quick and I'll show you if you type it in another way what happened. All right, so look how I typed it in this time. Basically what this is doing is it's taking log 2 and dividing by 12 and then it's multiplying by log 241 over 240. So you would need to put parentheses around that whole bottom portion, which is why I think it's just easier to go ahead and use the fraction bar. I think it looks a little nicer too. So 13.892 years should be your answer. And oops, so that is how long it's going to take for you to double your money. All right, last problem. How long will it take to turn $4,500 into $7,000 given an interest rate of 2% and compounded continuously? So this time we're dealing with good old PERT. And we're turning 4,500 into 7,000. So 7,000 is here. Interest rate 0.02, and we're finding t. All right, so this is just a regular exponential problem. Let's go ahead and divide 7,000 divided by 4,500 to get that e by itself. Make sure you math frac that. Don't write it as a decimal. So 14/9 equals e to the 0.02t. And now we'll just go ahead, we'll natural log both sides. So we'll get that cancellation that occurs. And then we can just go ahead and divide by 0.02. So I have natural log of 14/9. I'm going to make sure that's in parentheses. And I'm dividing that by 0.02. And I get 22.092 years. All right, and that is your lesson on compound interest. Let me know if you have any questions. Have a great day. Bye.